Math 1314, Tyler Junior College, Section 1.6, Other Types of Equations. The final type of equation we're going to review, or rather introduce, are absolute value equations. Now you should be familiar with the absolute value symbol. It's a pair of vertical lines. But do you remember what absolute value means, or what absolute value does? A lot of people think they know what it means, but they don't. They just know what it does. For example, you may know that the absolute value of 3 is 3. And you may know that the absolute value of -4 is 4. So what you may think you know is how this is working. What most people say about absolute value is it turns things positive, which isn't wrong. 3 is already positive, so that leaves it alone. -4 is negative, so it turns it positive. The word absolute value means what is the size of the number regardless of its sign, but that's not really what it means. What absolute value really is a question. The question that asks of a number is, how far away from 0 are you on the number line? So for example, if I were to ask you what's the absolute value of 3, what I'm asking you is how many spaces are there between 0 and 3 on the number line? And the answer is 3 spaces. For the absolute value of -4, the question it's asking you is how many spaces are between -4 and 0 on the number line. And the answer is there are 4 spaces between -4 and 0 on the number line. It's a distance measurement, which is why it's always positive. Now, if you're going to get cute and say, can't distance be negative if you go backwards? Now you're talking about vectors, and that's not what we're talking about. Distance is always positive, or rather I should say non-negative, because it's possible for a distance to be 0. Absolute value of 0 is 0. So how does that help us here? Well, think about what this equation is saying. This equation is saying the distance between 0 and x minus 3 is 7. Well, if I'm 7 spaces away from 0, where am I? It depends. If I go to the right, I'm at 7, but if I go to the left, I'm at -7. So what this equation is saying is x minus 3 is back here, or x minus 3 is over there. In other words, x minus 3 is equal to -7, or x minus 3 is equal to +7, which makes perfect sense because these are the two numbers whose absolute value is 7. Whatever's under my hand has to be 7 or -7. Well, these are easy to solve now. Add 3, get x equals -4. Add 3, get x equals 10. And yes, it's pretty much that easy. But let's generalize this before we do another example. What do I mean by generalize it? Well, write a how-to list. How to solve absolute value equations. Let's set up another one, and as we go through it, we'll set up some steps. This one's going to be a little bit more involved, but not a whole lot more involved. Let's say I ask you to solve 3 times the absolute value of 2x plus 1, close the absolute value, and then -4, and we'll set that equal to, let's make that equal to 26. Obviously, this has more junk in it. The trick to an absolute value equation at the beginning is the same as the trick to a lot of equations. Isolate the problem. Isolate the obstacle, if you will. In this case, the obstacle is the absolute value. So before we do anything, we need to isolate that, and that is step 1. If necessary, isolate the absolute value. If necessary, isolate the absolute value. In this case it is. In the previous example it wasn't. So we just need to get rid of the 3 and the 4 the same way we would normally do it, in the same order we would normally do it. So starting with the -4, add 4 to both sides. It's been a long day. Add 4 to both sides. And that would give us 3 times the absolute value of 2x plus 1 is equal to 30. But we still haven't isolated the absolute value yet because it's multiplied by 3. So if we divide both sides by 3, we can cancel the 3 on the absolute value, leaving the absolute value 2x plus 1 is equal to 10. All right, so mission accomplished. So what's our second step? Well, I'm not going to draw the number line, but what this equation is saying is that 2x plus 1 is 10 spaces away from 0. If I go to the right 10 spaces, it lands on the number 10. So 2x plus 1 might equal 10. But there's another number 10 spaces away from 0 to the right. So I can move it to the right, to the left. My right, your left. If I go 10 spaces to the left of 0, that puts me at -10. So 2x plus 1 can equal -10. And just to mess with your head, for those who watched the video about complex numbers and I showed you where imaginary numbers live relative to the number line, what if this lived 10 spaces above 0? We won't go there. So what did we just do here? Well, we basically rewrote the equation. We rewrote one absolute value equation as 2 non-absolute value equations. So how can we capture that as a step? Rewrite the absolute value with something on the inside. So I'm going to write the word inside the inside, equal a number. We write the absolute value of the inside equals a number as both. Well, what did we rewrite it as? Well, we put the inside equal to that number. So inside equal to the number, and the inside equal to the negative of the number. That gets rid of the absolute value, warning, asterisk. When the time is right, I'll tell you why. At this point, I know what's going to happen. We're going to finish solving. I'll go ahead and get the asterisk ready down here. Okay, these are easy to solve. Subtract 1 from both sides. That'll give us 2x equals 9. Divide both sides by 2. Oh no, a fraction. That'll give us x equals 9/2. Same moves over here, it's just we're starting with a -10. Subtract 1 from both sides. 1's cancel, and we get 2x equals 9. No, -11, excuse me. I overlooked the negative on the 10. And then divide both sides by 2, and we get x equals -11/2. So our answers are 9/2 and -11/2. Okay, that's went pretty smoothly. What could possibly go wrong? Well, one thing can go inconvenient, but another can go wrong. The inconvenient thing is the last move, finish solving. The difficulty of solving these will hinge on how complicated the inside of the absolute value is. For example, if the absolute value had a square in there, it would be a quadratic equation at this point, 2 of them. Or if the absolute value had a square root inside of it, then we would set up a square root equation and solve both of them. So that's one thing that can go inconvenient, but what can go wrong and what's up with this asterisk? Let me see how much time we have on this video. I may be able to finish it in this video and not start another one. Yeah, we'll do it in this video. We're approaching the 10-minute mark, but I'd rather have a little bit longer video than create one more. So I'm going to set up one more equation and see if you can figure out what's going to go wrong. So what's that equation going to be? Let's get it set up and then I can finish erasing. Let's solve. I'll take it down a couple of notches. The absolute value of x minus 3, close the absolute value, plus 12 is equal to 5. This one still requires the first step, but there's less stuff to get rid of. And the inside of the absolute value has less pieces than before, so finishing the last step should be quicker. But do you see what could go wrong here? If you did, great. If not, let's just start solving it. Step 1, isolate the absolute value. Okay. There is a 12 outside the absolute value. We need to get rid of it. So we'll subtract 12 from both sides. That'll cancel the 12s. And on the left, we're left with the absolute value of x minus 3. But what are we left with on the right? 5 minus 12 is negative 7. Why is this a problem? What does absolute value do? Turns things positive. What does the absolute value mean? Distance from 0. Distance is never negative. I'm trying to find an absolute value that's equal to negative 7. Well, here's some news. An absolute value will never be negative anything. At the very least, it will come out 0. Usually it comes out positive. This equation has no solution. Why? What do you think the asterisk is going to say? Remember, we were on step 2. Rewrite the absolute value of the inside equals a number as these two equations. But what's wrong with that number? It's negative. So the asterisk is, if this number is negative, comma, there is no solution. And it's important that you pick up on that. Excuse me, there is no solution. And it's important that you catch it, because if you don't, you'll go to the next step by setting this equal to that number and this equal to the negative of that number. So you would set up x minus 3 equals negative 7, and x minus 3 equals the negative of this number, which is positive 7. Go on about your business and solve them. You would get negative 4 and 10, and go about your business and miss the question. If you check either one of them, they both fail. But there never should have been solutions in the first place, because when you get to this juncture, if your absolute value is attempting to be a negative number, shut it down, problem over, no solution.